Get the recording going. Let me ask if anyone has homework questions that they want to talk about. We could start with that. Homework 5 is due on Monday. If you haven't started it yet, that's fine. I realize that you got plenty of days left. No worries. I will tell you that there is, most of it is things you've already done before. There's very little in the way of making new variables. So the last homework had a lot of sort of new coding things. This homework has not a lot of new coding things. It's more of just sort of a step back. Let's review what we know how to do. There's only one new concept, the idea of figuring out how to jointly test for the contribution of more than one slope to the model at a time. That's the one new concept. So the idea of testing the change in the R-square that results from adding in multiple new predictors at the same time via contrast in SAS, via test in Stata, and in R, it is GLHT, by the way, General Linear Hypothesis Test. So Fayaz, if you want to do all of this stuff in R, you could do that. I haven't tested the homework in R the way that I have in Stata, but I'm pretty certain you should get the same answers for models of this
Tried
scope.
the first one. I revisited the first homework and it's doable.
Yep.
Yeah, I get all the instructions on SAS, so it's much easier to do, go that route.
Good. Good. Yeah, the if you keep taking advanced classes, there is definitely a push towards R and most of them. I've just recently joined the R Club kicking and screaming this year, so it is one thing to definitely try to add to your toolbox if you can. Wait, you went back just for fun?
Just like, I just because I need to have R open at all times because I'm working on my second year project. So I think of a code chunk, I think of something that I could put into my equation, and I just go to it. That's why, I revisited just a few questions, not the whole thing.
Well, good news for you. I plan on leaving open the 6242 homework system indefinitely. So if you want to go back and like redo your homeworks using different programs, knock yourself out. That's fine with me because this class is no longer being offered for the foreseeable future, so it's going to stay up. Yes. You didn't know that? Yeah, they killed it off. The powers that be want less redundancy, so now everybody gets to take intermediate instead. But intermediate has changed, so a
This was a
compromise.
nice ramp. If you don't have any knowledge on SAS or Stata, this was like a really nice little ramp. Like if you start in the middle, I don't know if it's going to be more difficult for some students, even for more advanced students, it might be difficult.
Who knows? It's a different set of skills, I think, to understand the modeling than to understand the coding, and then to understand the numbers that are coming back out at you. So it's like there's sort of three different areas, and people can come into the process with different levels of experience and familiarity and comfort with each of those areas. So who knows? But anyway, homework questions. That's where I was going with this ramble. Does anyone have any for me? Not yet?
I mean, yes, but I don't know how to ask them, so we'll get to that later. And
Okay.
if anyone else hasn't started and uses SAS and wants to have a homework party this weekend, not opposed.
Well, there you go. You can make it a bonding experience. As much bonding as one can do over Zoom, at least, right? Which we're all much better at than we used to be. I can tell you that much. So, well, if we don't have any group homework questions, we can pick back up on where we were last time. Let me get the this thingy out of the way. Do you want me to turn on the closed captioning thingy? Is that helpful or is that distracting? It's helpful? Okay. Well, in case I haven't mentioned this before, I do this in my other class because there's several folks that like that. If it's annoying to you, you can shut it off. So I am immediately going to turn it on so that it's working and then hide it from myself so that I don't have to see it mangle all of my words. Because that is, it is not as good as the transcription technology that YouTube uses. I can tell you that much. YouTube is much closer to a actual representation. So, anywho, what were we talking about last time? And here's a hint on slide 10. What do you remember? And I'm frozen. Zoom not connected. Connecting. Mm-hmm. Or, okay, let me make sure that it's still going. Okay, I think we're good. Now we're recording. Okay, we'll see what we can do. Now the question that I had, what do you remember from Garbage Day, otherwise known as Tuesday?
Simple main effects is very poorly worded because it's the least simple of all of them. But they happen when your, say, X variable shows up in multiple places.
Yes. So what we used to just call a slope to start off with, right? Fixed slope to be specific because it's a constant. That becomes a main effect slope at some point because it's talking about the contribution of the variable by itself, like its own contribution to the model. And then we have simple main effect as another layer of terminology, which is terribly worded, inaccurate, and condescending at the same time, right? To call anything simple is just a disservice to your readers. So that's one thing I never ever want to do is put words like obviously, clearly, evidently, like those sorts of things that make your reader feel stupid if they can't immediately follow. Simple main effect has that same connotation, but it comes from an ANOVA sort of framework, the way that people talk about that, where you have like marginal means and cell means, and you have simple main effects as differences between cell means. That's where that terminology comes from. But it is a function of a predictor when it is included in more than one term in the equation. So as Jen said, that is correct. And when would you want to do that? Why would you want to put in a new term that's like x times z as a predictor? Any
I'd
ideas?
say if they're somehow related to each other.
If they're related to each other, keep talking.
So if they correlate with each other different, or if they relate to each other and then relate to the outcome differently when together. Yes, interaction, thank you.
Yes, there we go. Yes, so predictors can relate to each other always. The model figures out how much of the relationship of each predictor to the outcome that it has on its own uniquely. That always happens. So you address relationships between predictors anytime that you put them all together as predictors in one model. And so what you're talking about is that they relate to the outcome differently when they're together. Yes, that's the idea of an interaction term. So when you have a predictor multiplied by another predictor, that is an interaction term, which makes the effect of each of those two predictors conditional on the other. That's what we're talking about. So we had an example from last semester that you recognized, Solomon, can't remember his last name. He had an example of the relationship between camera use and grades. Remember this at the end of class? So I wanted to do a little impromptu thought about that. Let me pull up my friend Excel for a second. Move it over to this window. Excel is my modern day whiteboard. So if I had a linear model, that might look something like this. So let's say that grades is the outcome. We're just going to type quickly here, beta 0 plus his hypothesis was about camera use. So I have beta 1 times camera, and he thought that camera use mattered only in smaller classes. So that type of idea, I'm going to deliberately call that beta 3, would be operationalized as something like that. Camera use times class size, plus E. Now, is that model acceptable as I have written it? Or did I forget something?
You need beta 2?
Yeah, I did that on purpose.
Okay.
We call that foreshadowing.
Okay.
What does beta 2 need to be attached to?
Class size.
Yeah, and why is that?
We need that main effect of class size, right?
We do need the main effect of class size. The interpretation of beta 3 as the interaction term is only valid if we have the main effect of class size in the model. Otherwise, we're assuming that it's perfectly zero. So I'm going to stick that in there. Beta 2 times class size. There we go. So that looks like a model. Now, in terms of the coefficients, we would say beta 1. Do we expect that to be positive or negative? Positive. Camera use helps your grades. Camera use is a proxy for engagement, so to speak, attentions, things like that. What do I have to know, though, in order to interpret what beta 1 means? Do you remember the rules about what beta 1 means in the presence of an interaction? Nope, not yet.
The
Whoa.
grades. Sorry, Alex. Do you have to know, Lisa, like what the grades are to start with?
Not what the grades are, but the other variable in the problem.
Class size.
Yeah. So this beta 1 is specific to when class size is 0.
Okay.
So we would have to make sure that we center class size, because a class size of 0 is not a class. Or it's a really bad class that no one wants to go to. I'm not really sure where the logic is on that. But let's say that we centered class size so that it's at the mean. So at the mean class size, we would expect maybe a positive slope, I'll write that out here, of camera. I'll put this at class size equals 0. What do you think about beta 2? Positive slope, negative slope, or 0 slope in my little story here?
Negative slope.
Negative slope. Do you think it's harder to get good grades in a bigger class?
A bigger class, then you probably get a decent percentage not doing so well on exams, and not doing so well in terms of grades.
Yep, that makes sense. And so likewise, we would have to know how camera use is centered. So if we have this as 0, meaning you don't keep your camera on, 1 meaning you do keep your camera on, then this would be a negative slope of class size at camera equals 0. Now the tricky part, the interaction term. What's the sign going to be? The hypothesis was that the use of a camera matters more in smaller classes.
I was going to guess less positive. Would that be correct?
Yeah. And so what does less positive have to be then in terms of the sign of this coefficient to make it work? In this case, it's going to be 50-50 chance.
Positive, negative.
It's negative. This is super tricky, especially when the two main effects are in opposite directions. But we're focusing on this one right here as the predictor, and class size is the moderator. So what we want to have happen is as class size decreases, the slope becomes more positive. So the sign has to be negative, meaning that camera use matters less in large classes. Camera use matters less as the moderator goes up would be a negative interaction term. You with me? Ish. So then
Is
this
it-
one, yeah, go ahead.
Or is it fair to assume that anytime that we're going, like, let's say if we go less negative, would that always be a more positive rate?
Good
Or
question.
would that be positive, I guess?
Less negative and more positive are heading in the same direction, but they are different things.
Okay.
So, like, less negative means it's still bad for you, it's just less bad, right? But whereas moving towards the positive direction means that it is a bigger positive effect. And
Okay.
I once had a student debate me on this because, like, you're moving in the same direction on the number line. How are these different? And I referred to an example of weather forecasts. So in January, when you get the weather forecast and the temperature is predicted to be higher than the previous day, it usually says something like, not as cold. It doesn't say warmer. It's like, no, we're still at 20 degrees, just not 10. That's not warmer. It's just not as cold. Likewise, in the summer, if you go from a 90-degree day down to an 80-degree day, that's not as hot. So I argue that thinking about the sort of the reference point for the slope that's being moderated and the direction of it is an important part of the story. But the reality is that these sorts of models predict basically an infinite number of possible slopes for the effectiveness of camera use as a function of any value of class size. The one that happens to be given by the model is just one of many. So in addition to teaching you how to interpret simple main effects, which are anything but simple, I want to show you how to get other simple main effects at other values of the moderator as well. So if I take the emphasis off of this one, then this one would be a more negative. So class size would be worse. The effective class size would be worse in people who put their camera on. So that may or may not make sense, but the reality is that this interaction term does two things at once. It talks about, in this example, how the effect of camera use varies by class size, and simultaneously how the effect of class size varies by camera use. So when you're trying to talk about moderation, I think it's helpful to phrase it in ways that allow your hypothesis to be confirmed or disconfirmed. Because if you have a particular pattern, that implies a pattern of positives and negatives coefficients to go with it. So like if we had ended up with a positive interaction slope instead, then that would totally change the story. I'd still say that class size moderates camera use, but now class size matters more in bigger classes, which is completely opposite of what he had anticipated. Okay, how are we doing? I sound like the annoying character from Phineas and Ferb. Any of you watched that cartoon? Oh, Jonathan's gotten Huey into it lately. That is the worst. But I know there's one of them that she always goes, "How's it going?" I don't know which one that is. I just know that she says that. So I don't want to be that character, but how's it going? It's going. Yeah. Children's cartoons are the worst. You're all going to find out someday. I would recommend, as soon as possible, investing in a pair of Bluetooth headphones for your darling child so that you never have to listen to their crap shows ever. It has been a total game changer. I am dead serious. We have Bluetooth headphones for all of his devices and at every TV in the house. That way, no matter where we are, we don't have to listen to it. So, where I do have to listen to it is when Daddy watches it with him. No, there are plenty of crap shows you will learn. It's thank goodness Caillou got canceled. He never got to that one, but apparently that was the worst show in the history of shows. Paw Patrol's also pretty bad. One of the only ones I can stand is Peppa Pig. That one is I think pretty cute. So, anywho, you want to see some more examples? Talk about this a little more. Interaction terms. Cinematic masterpiece. Oh, Yo Gabba Gabba. Oh my goodness. Don't bite your friends. No, they sing songs about that. It's a whole thing. Anywho, I watched the Smurfs when I was little. She-Ra. Things like that. Jem and the Holograms. That was pretty awesome. That one's still around. I'd recommend that. So, we went through this one last time. Let me bring this back up again. So we filled in this table together. I haven't seen the rebooted She-Ra. I will have to look for that one. So there's only 4 kinds of interaction terms. We just have to figure out which of the 4 you're dealing with, and then you'll know how to talk about it. So if I had a main effect slope of x here that was positive, and I had an interaction term, it's beta 4 in this model that's positive, then the way that I would talk about this is that the effect of x, so the slope as the unit of the sentence here, the slope for x becomes more positive as z increases. That's the way I would talk about it. If I have a positive slope for x, but the interaction term is negative instead, then I would say that the slope for x becomes less positive as z increases. So x would have less of an effect at people at higher levels of z in that case. The opposite then, if we have a negative slope as the unit that we're moderating, and it's paired with a negative interaction, then that is a more negative slope as z increases. And then finally, a negative main effect slope paired with a positive interaction means that the effect of x becomes less negative as z increases. So that's it. There's only 4. And once you look at the signs, you know how to talk about it. Here's another play-at-home one. So this is designed to illustrate the importance of centering, which historically in multiple regression, up to models that have interaction terms, people typically don't care about centering because the fixed intercept is rarely of interest. But I think it's important for all your parameters to be interpretable, which is why I start off by having centered predictors. But it's especially important in the context of interaction terms. So do you want to play along with me here? Ready to play? Okay. Do you want me to type as we go here? Would that be helpful? Yes? Okay. I can do that. 1 second. Just gotta exit out of the show and then hide this thing again. There we go. So I have a story here. Let's say that Y is student achievement as measured by GPA on a scale out of 100. Let's say that X is parent attitudes about the importance of education. Let's say that it is a Likert scale measured from 1 to 5, where more is better. And then Z is parent education level. So let's say that that's measured in years of education. So here's my model. I've got beta 0 as my intercept, the main effect of attitudes, the main effect of education, and the interaction term. And let's say that the numbers that showed up on my SAS, Stata, or R output were these numbers right here. So then the question is, how do I describe each of those fixed effect coefficients? So starting off with the intercept.
The achievement score when the parent's attitude and the parent's education are 0.
GPA achievement. When, say that last part again.
When the parents have no attitude about education and have no education level.
Ding. Do you think I have anybody like that in my sample? Yeah, odds are not good that I'm going to have a research participant who's never been to school because they probably couldn't understand the instructions or read them. But also look at this one. This isn't even possible on a scale of 1 to 5. So it's maybe not surprising that your expected GPA percentage is so low when you're talking about a reference point that's clear outside the data. Now this one. Slopes are always the change in y for a 1 unit change in x, ... but this one is conditional. So how do I talk about this one?
The GPA when the GPA score when the attitude level is
Not GPA. So
not
we're,
GPA,
we're interpreting a slope.
right?
So slopes are always some form of the change in y for a 1 unit change in x.
So the change in GPA for a 1 unit change in attitude when education is held constant.
So change in y, change in GPA per unit at
Change in
when,
education is held as a constant.
not just as that constant.
When we are controlling for education.
You are holding it constant / controlling for it anyway when both predictors are in the model. This is an extra layer of conditionality. It's when
And there's no interaction.
when there's, in this case, it's when education is 0.
Yeah. Okay.
So why is that? Because we're talking about the idea of the effect of attitudes on GPA. Like that's the thing we're trying to interpret. And beta 1 only holds the slope for attitudes when this latter term zeroes out. Because attitude shows up over here too. And the only time when this latter interaction term zeroes out is if you're at education equals 0.
Can you explain that again, Lisa?
Sure. So in terms of layers of interpretation here, we started with models in which you had only one slope, right? So we call that a bivariate slope because it's just this x with this y, 2 at a time. And it is all of the relationship between x and y. Once we add another variable in here, such as if this is our x is attitudes and we're going to add in education, then the slope for attitudes describes the unique slope holding education constant or after controlling for education or whatever phrase you want that conveys that idea, right? It's the non-common part of the Venn diagram is what that slope refers to. So that would be the case even if this latter interaction term wasn't in the model. So without the interaction term, beta 1 is the effect of attitudes holding education constant, and beta 2 is the effect of education holding attitudes constant. So that's what I refer to as a unique effect, but marginal, because it applies to everyone in the sample. Now I've got another layer to it where because of this additional term, if I want to say, how does the model tell me to what extent attitudes matters in predicting GPA? Well, the model says attitudes matters here and over here. It shows up in 2 places. In other words, the slope of attitudes is a linear combination of 2 different things. So consequently, this slope of 1 is only the total effect of attitudes when this latter interaction term is not contributing. And that happens when education goes to 0. Then this whole term drops and the full effect of attitudes is right here. Holding education constant. So this one is not only holding education constant, but constant at 0 specifically. That is the simple main effect, where the word simple actually just means conditional. Cough, cough, homework question. So like in homework 5, there were no interaction terms. So each of those effects is marginal or unconditional. Like this is the slope of GRE scores for everybody. This is the effect of being afraid of statistics for everybody. Yes, your homework is a real life graduate school storyline today. Turns out being afraid of statistics is bad for you. I'm going to spoil this ending in my story and in life. But none of you is afraid anymore, right? We're past that point. We're in like week 13 or some shit like that. No one's afraid anymore. So yeah, so this thing is holding constant the other variables in the model, but also conditional on the variables it interacts with. So this is the slope describing the change in GPA for a 1-unit change in attitudes, specifically when the interacting variable of education is 0. That's a mouthful, but does that actually mean anything? Do I care about the differences in the effective attitude amongst people that aren't even in my sample? Probably not. Probably not. So right now we are 0 for 2 with meaningful parameters in our model. How about beta 2? Does it get any better? How do I talk about beta 2?
Change in GPA per unit education when attitude is 0.
Per unit ed when at is 0. So it's the mirror image because education is also a simple main effect. So not only did it not get better, arguably it got worse because attitudes equal 0 can't even happen. So 0 for 3. Now the last one. What do I do with the coefficient beta 3? This is tricky because most people want to start out the sentence the same way. Change in GPA for a 1-unit change in both attitudes and education? No. There is a layering system that happens in place here. The role of a two-way interaction is to describe what happens to the main effect slopes. The role of the main effect slopes is to describe what happens to the predicted outcome. So if we follow that hierarchy, the way that I would talk about the effect of the interaction term using attitude as the moderator would be to focus on what happens to the slope for education. So I would say it is the change in beta 2 per unit education in this one. So it's not GPA that's being affected by the interaction term. It's the slope of one of the variables as a function of the other. And given the coefficients here, what happens is that the education slope is 2 when attitudes is 0. For every additional value of attitudes, that 2 becomes more positive by 0.5. So the interaction term changes the slope of the predictor as a function of the moderator. So which of the 4 kinds is this pattern? Attitudes makes the effect of education more positive, less positive, more negative, or less negative.
More positive.
This is a more positive in both directions, actually. So then how do I talk about it if I want to change which is the predictor and which is the moderator? Let me write that out better. There we go. What goes here?
change in beta 1 per unit attitude.
There it is. It's unit. Can't type in front of people. Yeah, it's parallel. It's the change in one variable's slope per unit of the other variable. So in practice, when you're fitting these models, odds are good that you have a research question that phrases one of the predictors in particular as the predictor, whereas the other is the moderator. So for instance, in the camera use and class size example, the idea that camera use matters more in smaller classes, that phrasing says that camera use is the predictor and class size is the moderator. If I had hypothesized that class size matters more if your camera is off, then it would be the opposite. But mathematically, they are indistinguishable. The interaction term moderates each of the other slopes to the same extent. How we doing?
So Lisa, does it have to do with the order of the way something's phrased, or is it could be a different order and still phrased the same? I was not very clear what I said, but basically, like, you were saying, like, you switched the order of, like, class size and camera on or off in those examples. So is order a good way to think about that in terms of how it's phrased, or not, or more like the language of how it's phrased?
I would say the language.
Okay. Okay.
So another way to say that camera use is the predictor and class size is the moderator would be something like, as class size decreases, the effective camera use increases.
Okay.
It's like, as something changes is a dead giveaway that that's a moderator.
As something changes. Okay.
For a quantitative moderator.
Yeah.
So if you had something like camera use matters more in stats classes than English classes. Like giving the two situations in which you're evaluating the effect of a slope makes those two situations the moderator.
Okay. Got it. Okay. Thank you.
Sure. Thanks for the question. So we could use this equation, even though 3 out of the 4 terms are kind of garbage. The equation still works because it tells us for any combination of these predictor values, what the expected GPA would be and what the expected simple slopes of these variables would be. The trick is knowing how to ask for it. So for instance, if I wanted to generate a predicted outcome for somebody with attitudes equals 3, so mid-range on that scale, and education equals 12, then I plug in those values into this linear equation, and with the coefficients, that gives me a total of 75. So the model still works. It's just that having these two parameters be meaningless is a recipe for misinterpretation. Because let's say that we looked at this output and this slope of 1 was not significant. So you might be tempted to say, oh, attitudes don't matter. Right? If a slope is not significant, that means it's not related to an outcome. So colloquial language would be like, that doesn't matter, or is not different than 0. But that conclusion is overgeneralizing the situation. It's not that attitudes don't matter. It's that they don't matter in people who've never been to school. But this model suggests that the extent to which attitudes matter, the slope, becomes more positive, stronger as attitudes increases. So at some point, that positive slope is going to cross the threshold for significance and it will matter. It's just that attitudes matters differently for different people if the interaction term is significant. So let's fix it. I centered my predictors to show you what would happen. And here is the new fixed effects solution that I would get if I centered attitudes at 3 and if I centered education at 12 years. So now, how do I talk about beta 0 given this new phrasing of my predictors?
Is beta 0 going to be the same as before?
It was 30 before, and now it's 75.
Oh, it's 75. Okay.
Yeah, as a consequence of me changing how the model is phrased. So what does 75 refer to?
Like when there is no attitude, no parents' attitude, and no years of education from parents, right?
So still 0, but now what 0 means has changed.
Okay. Oh, okay. Yeah, attitude at level 3. Oh, yeah.
So we have expected GPA for somebody with mid-range attitudes and a high school education. Their kid is predicted to have a 75. So that could happen, right? These are plausible values within my example. So I'll start you off here on beta 1. Change in GPA per unit change in which predictor is this? Attitudes for
Education equals 12.
Yep. Education equals 12 is the new 0. Orange is the new black. Education of 12 is the new 0. I've never watched that show, though. I tend to stay away from shows with any violence in it. I have the emotional stability of a 10-year-old girl when it comes to watching shows with, like, people getting hurt. I just really don't like that. So, anywho. So now we're talking about attitudes, which previously had a slope of 1, now goes all the way up to 7. Huh. How did I know that? Magic? Voodoo? A little bit. I'll show you in just a minute. Beta 2, I'll start you off. Change in GPA per unit. Which slope is this? This is Ed 4.
Attitude equals 3.
Yes! We're cracking the code. And this used to be a coefficient of 2. Now it's 3.5. Last but not least, the interaction term is exactly the same as it was before, even though both predictors are centered differently than before. Now, why might that be? Why is the interaction term unchanged despite the fact that we've recentered our predictors to change what 0 means?
The relationship between the two hasn't changed?
Yes, keep talking.
I don't have anything more to say. I'm throwing it to someone else.
He's phoning a friend. So do you remember the 3 types of slopes we talked about last time? There's bivariate marginal for when a predictor is all by itself, and it applies to all cases in the data. There is unique marginal when a predictor is paired with other predictors, but there's no interaction terms, and so each slope is the slope for everybody. And then there's unique conditional, which describes these 2 slopes that are controlling for everything else in the model, but they're specific to the 0 value of any interacting predictor. The interaction term is unique unconditional, though. And I'm frozen.
Like, honestly, I'm surprised people just didn't transition to that during the pandemic instead of Zoom, but whatever.
Whatever. Well, the university has a subscription that we're all supposed to use. You know where I went with that? Is Twitch the hip hop dancer? That's where I went. No? No, he's awesome. So it was So You Think You Can Dance. He was one of the contestants on there, and they bring him back every year as an all-star, like to dance with the contestants because he's just so damn good. I love Twitch. So clearly there is a divide here in points of reference, but yeah, well, we're just going to keep going with our crappy technology and our crappy TV shows, and we're going to make the best of it. That's what we're going to do. So what I was saying before I exploded, yes, thank you, Emmy. I'm not the only one. I really hope that So You Think You Can Dance can come back. It got canceled because of COVID last year, and I really need to watch 19-year-olds dance their heart out. It is such a feel-good show. I really need that in my life right now. Anywho, you need this in your lives. Trust me. Interaction terms, it's the thing. This interaction term is a unique effect because it's controlling for all the other stuff in the model, but it is unconditional. And I know that because there are no other terms in the model that have both attitudes and education. There's only one instance of that combination. So another way of saying it is that education moderates the slope of attitudes the same for everybody. Unconditional. Education moderates the slope of attitudes equally for everybody, and attitudes moderates the slope of education equally for everybody. It's unconditional. That's why the number didn't change when I recentered the predictors. So the interpretation then is exactly the same as before. It's the change in each slope for a 1 unit difference in the other predictor. Okay. Questions? There, I mix it up instead of asking how's it going. Questions? Do you want to see how I knew what the new answers would be? Why not, right? I got some more slides that we can fill in together here. Because we can figure it out as a linear combination. So let me show you how you can ask SAS, Stata, R, and some packages in SPSS to find out these sorts of things for you. So here's an example of how I would get a new predicted intercept. How would I know what that should be? It was 30.
Dr. Hoffman, you're
Yeah.
not sharing screen right now.
Thanks. Oh, goodness. And I'm probably paused. No, I am recording. I am recording the screen that you're not seeing. So we do have that. You know what's funny is that the closed captioning came back on automatically, so I think I just thought that y'all were seeing this. But no.
I have a quick question too. So for your previous slide, would then beta 3's, like the description, still be the same as before then?
It would be exactly the same.
Okay.
Because it is unconditional. Yes, indeed. All right, now we can see. I'm on slide 15. And I don't think I'm frozen. Not right now, anyway. Stay tuned. So I'll show you how to get the magic behind how I knew what the new intercept was going to be and how I knew what the new slopes was going to be. So first the intercept here. So this is my model that has attitudes centered at 3 and education centered at 12. So we can write estimate statements in SAS, or LINCOM statements in Stata, or GLHT statements in R to ask for predicted values for any combination of predictors. You guys already know how to do this, or at least you've done it before successfully, even if you don't remember. The key to generating a predicted outcome that is correct is to remember to include every single fixed effect that's in the model. All of the fixed effects, the intercept and all the slopes, have to be considered. So when I type intercept 1, what I am asking is to build a linear combination that starts with 1 of whatever beta 0 is going to be. So the word intercept, or the word constant here in Stata, is a placeholder for what beta 0 is going to be in the solution provided by the model. By the way, solution means the answers. So that's a fancier way of saying the answers. Attitudes here refers to what beta 1 is going to be. So if I want a predicted outcome for somebody with a very high level of importance of education attitudes, that's 5, what goes here? Got 1 vote for 1. Attitudes is centered at 3. So if I want a predicted value for somebody with a 5, 2. Yes, because 5 is 2 higher than 3. Do the same thing down here. If I want a predicted value for somebody who has 16 years of education, let's call that a bachelor's degree, what goes here? 4. Very good. So ed refers to what beta 2 is going to be. The value refers to what goes in parentheses as the multiplier. Likewise, at by ed refers to what beta 3, the interaction term, is going to be. What goes here? Yeah, this is still a finger question. You got to work for it, though. Yeah, 8, because 2 times 4 is 8. Ta-da! So same numbers go in the Stata code down below. It just looks a little different. What goes here if I want attitudes equals 1 as my predicted? Yeah,
-2?
Yeah, -2. You got it. And then I have to move up here and change the spacing so that everything is aligned. Otherwise, I can't handle it. What goes here if education is 12?
That's where we zeroed out.
That is already zeroed out, yep. So technically speaking, I would not even have to write this part because it's 0 if you don't write it, at least for quantitative predictors. And what goes here?
0 again, because it's -2 times 0.
Ding. And last but not least, if I want attitudes equals 3, what goes here? 0. Yeah. And what goes here if it's education equals 20?
8.
Yeah. And then what goes here?
Another 0.
Yes, because 8 times 0 is still 0. So these are linear combinations of the model parameters designed to give you predicted outcomes for any kind of person. So even if your predictors are centered or not, the model will still tell you what y is expected to be for anybody based on the predictor's values. Okay. This going well so far? This much? Okay, yes. So you know how to do this. You've had practice doing this. And the benefit of doing it this way as opposed to getting out your calculator or Excel is that each of these predictions comes with a standard error. So that way you can put error bars around your predictions in making pictures. And when the model gets much more complicated, such that the standard error is going to change based on other things, this still works. Now the trickier part. How did I figure out what the new slopes were going to be after I changed my centering method? So I want to teach you the strategy by which you can figure out how the model predicts what the simple main effect slopes are going to be for any values of the moderating predictors. So any of these slopes can be described in the same way. It's whatever it is by itself plus how it's moderated by any interaction terms containing it. So there's 3 steps. If I tell you what's the slope of attitudes going to be, step 1 is to figure out which terms in the equation have attitudes in it. Step 2 is to factor out the common variable for which you want the slope. And then step 3 is to plug in the values of the moderator for which you want the slope of the other variable. And then the software will figure out what it should be. So for this example, let me make this big again here, assuming it will let me. There we go. So step 1. So for instance, if I want the slope for attitudes, I go into my model and I find all the terms that have attitudes as part of them. Notably, I don't have an intercept because what I'm trying to figure out is a slope. Intercepts don't go into slopes. I also do not have the main effect of education by itself because that has nothing to do with attitudes. I only have the 2 terms that have attitudes in common. Next step, nope, not next step, psych! To get the education slope, same process, where I have the main effect of education, I have the interaction term, I don't have the main effect of attitudes because it doesn't have education in it. Now, second slope step for real, factor out the common term. So I am taking attitudes minus 3 as the common variable for which we're trying to get the slope out and sticking it over here, and then here's what's left. So the slope of attitudes as given by this interaction model is this linear combination right here. The slope of attitudes for any person in the data set is going to start with beta 1 and then be augmented by whatever their value of education is times the interaction term. Likewise, to get the education slope, I factor out the common education variable, and here's the linear combination, that's what's left. So these are your ingredients for how to get the slope. By the way, here's how you would get the standard error for the new slope. You can calculate it by hand if you feel like it, but it's much more efficient to do that in a program. All right. Do you want to play? Or are we saturated enough for today?
Really quick, can you just explain more about factor out, like what that involves? It's buried deep in my math memory, what that is.
Yeah, so literally take the thing that is in common and move it to the outside so that the term in brackets, that whole thing is the multiplier of attitudes equals 3. So it's an algebraic rearrangement of the same information, but this linear combination corresponds directly to what the SAS and Stata code is going to look like to figure out what the slope should be. Okay. Jerome wants to play. We'll play a little bit. We'll call it good. So I have the equation repeated here. So the attitude slope then is this combination right here that will multiply attitudes that's been factored out. No guarantee on passing this level. Yeah, I know. It looks hard when you first start doing this, but once you see it, you can't unsee it. I always link this to the Magic Eye posters, right? Where you like stare and it looks like a mess, but there's like a sailboat in it somewhere. Ironically, I've never ever seen the sailboat in one of those pictures. I am incapable. But I hear that there's a sailboat in there, and once you see it, you can't unsee it. These things work the same way. Once you see the connection, you will be able to make it reliably. So if we do attitude slope, this little combination right here tells us how to do it. So I have two examples I want us to fill in. I have intercept equals 0 on both of them because the intercept is not in this little combination right here. You're not going to be bad. It's going to be fine, I promise. And we'll keep practicing this for the next 3 weeks. Hang on, I want to be able to type. Come on. You can do it. There we go. Now I can type. Stupid thing out of the way. There we go. We're right here. So what are the values that I have to fill in to figure out what the attitude slope would be for somebody with a 10th grade education? So keep in mind that the words here, the words are the betas. So in this combination right here, how many beta 1s are there? Not a trick
Just
question.
one.
There's one.
Just one.
Just one. So to make my attitude slope, I need 1 beta 1.
Okay, let me take a stab at the education one. Is that where we do the math here then? Do we trade out the 12 and the 10, so we have to do plus or minus 2?
Right idea, but not yet.
Dang it, okay.
The reason is because ed refers to beta 2. Ed by itself is beta 2. And in my little equation right here, how many beta 2s are there?
There are none.
Yeah. Because ed by itself has nothing to do with attitudes. So I go 0 here. Now say what you just said again, Jerome.
Okay, so we see the ed minus 12 in there, but we also see it, we're zeroing out at 10 now, or we're trying to go to 10. So I guess we'll go -2 there.
Ding. It's the value of the moderator for which you want the other slope. So this little equation tells me what the values should be. Let's do the next one and then we'll call it a day. What goes here? How many beta 1s do I need to make an attitude slope?
I can answer, or can I let someone else do it?
Oh, we got everybody answering. We got finger questions
Okay,
and
cool.
microphone questions. Yeah. I had someone from my other class once type into the chat window 1 finger. It's like touche. I hope it wasn't the one I was thinking of. That's Anywho, how many beta 2s are in this little linear combination here? None. Because this refers to the slope of education by itself, which is irrelevant. And if I want the attitude slope for somebody with education equals 18, 6, yes, nailed it. So by following this same logic, I was able to anticipate what the new simple slopes would be at another value of the moderator after recentering. So if I go back to my original equation here, if I want to know what the slope of attitudes would be for somebody, oh, damn you, Zoom. getting the unstable message again? We're good? All right. If I want to know what the slope of attitudes would be for somebody with education equals 12, then I do 12 times 0.5, which is 6, plus the one I started with gets me to the 7. And if I start with 2 for the slope of education when attitudes is 0, then to get to what it would be for 3, I take 3 times 0.5, which is 1.5, and add the 2 to it. So I've got 3.5 there. So that's how I knew what it would be. So in addition to getting simple slopes for other values of the moderator besides the one that is the 0 point in your equation, doing this type of programming statement also gets you that new slope's standard error and its p-value. So then you can answer the question, does attitudes matter in people with a 10th grade education? Does attitudes matter in people with an 11th grade education? Do attitudes matter in people with 12th grade education? So you can get significance tests for each unique slope on its way to being more or less as a function of the other variable. Okay. Questions? Isn't that so bad, right? It's okay. Good. Maybe not palatable yet, but we're heading towards that direction. All right, then it's not garbage day. That means it's Thursday. That means I say have a good weekend, and I hope to see you next week. Let me know if you need any help finishing your homework on Monday. How's that? All right, bye everybody. Thanks for playing.